Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is curtain raiser to probability. This is a part of our course called MCO3, Research Methodology and Statistical Analysis, and we are here in fourth block. So if we go into the backdrop and find out that IGNOU contents are in certain blocks, and then each blocks have certain chapters or units we used to call. So we have already covered the third block. Block 1 talks about research and data collections. Block 2 talks about processing and preservation of data, and block 3 talks about relational and trend analysis. So this all blocks focus more on the collection part, the preservation part, trend analysis part. Either it could be the collection of data through primary mode or secondary mode, or preservation of data through different mode, like a graphical presentation of data, or the diagrammatical presentation of data, or the way of preserving the data. Then the third block was purely focused on the trend analysis. Either it could be through correlation, regression, or this time series or index number. So this we have already covered in our preceding blocks. And the fourth block is a block which focused more on testing, or rather we can say more focused on executing the particular mathematical algorithm what we have used in our preceding session. So what we have learned in the preceding sessions, like statistics or the research, that we are going to test in this particular block. So this block is more focused on probability and hypothesis testing. And if you go into the backdrop, you will find out that the very first unit, that is unit 13, is focusing more on probability and probability rules. And then you have probability distribution, then the hypothesis testing is there, then various the test methods are there. Either could be the t-test, chi-square test, or ANOVA test. So we are going to focus on all those the testing methodologies in a very gradual manner in our coming sessions. But prior to going into the depth of that, we just want to throw a light that we are just focusing today on the curtain raiser to probability. So what exactly the probability is, we will discuss, and start with what exactly the test in research is. A test can be considered an observation or experiment that determines one or more characteristics of a given sample, product, process, or services. And the purpose of testing involves a prior determination of expected observation and a comparison of that expectation to what one actually observes. So you see how powerful the testing is. And when you are going to talk the testing in a statistical perspective, so there is a great purpose of statistical test. A statistical test provides a mechanism for making quantitative decisions about a process or processes. The intent is to determine whether there is enough evidence to reject a conjecture or hypothesis about the process. Now, what are the types of test statistics? Like there are various types of test statistics. There is a wide range of statistical tests. There are many different types of tests in statistics, like t-test, z-test, chi-square test, ANOVA test, binomial test, one sample median test. And choosing a statistical test like parametric test are used if the data is normally distributed. So what we are going to do, we have learned the statistical concept, the research methodology in our preceding session, and this particular block is more focusing on how we are going to test the particular statistical tool what we have learned in the preceding session. So in the previous unit we have discussed the application of descriptive statistics. The subject matter of probability and probability rules provide a foundation for inferential statistics, and there are various business situations in which the decision makers are forced to apply the concepts of probability. Decision making in various situations is facilitated through formal and precise expression for the uncertainties involved. For instance, formal and precise expression of stock market prices and product quality uncertainties may go a long way to help analyze and facilitate decisions on portfolio and sales planning respectively. So probability theory provides us with the means to arrive at precise expressions for taking care of uncertainties involved in different situations. So this unit starts with the meaning of probability and its brief historical evolution, because to understand the probability, I think we have to see the genesis behind the probability, why this probability had been created, and what are the purpose or the intention behind using the term probability. So people use the term probability many times each day. For example, physician says that a patient has a 50-50 chance of surviving a certain operations. Another physician may say that she is 95% certain that patient has a particular disease. So now the question is, why learn probability? Nothing is in life is certain. In everything we do, we measure the chances of successful outcomes, from business to medicines to the weather. A probability provides a quantitative descriptions of the chances or likelihoods associated with various outcomes. It provides a bridge between descriptive and inferential statistics. We have learned about descriptive statistics and inferential statistics, in our preceding sessions, and when the question comes about the detailed study, I think we emphasize more on the descriptive statistics, and when the statistics or based on, since in statistics based on the samples or the assumptions, so inferential statistics is very important, because from the large group of population we are just taking a small sample and then try to interpret the results on the basis of that small portion we have taken. So what we have learned in a preceding session, that we have a population and we have a sample. So probability is very important, because the whole and statistics and probability is helping us to get the clear result or the accurate result on the basis of the sample taken. So what is probability actually? In previous chapters we used graphs and numerical measures to describe data sets which were usually samples. So we have seen that the sampling, or if you go into the depth of the lectures which we have taken on sampling, either it could be the random sampling, or the convenient sampling, or the snowball sampling, or whatever it could be. So this sampling is going to be bifurcated in terms of random sample or non-random sample. So this probability is going to play a very important role, because when you extract the sample, this probability is provide you a way to get the best results from that sample, so that whatever the representation you have taken from the population is going to have a very clear picture about that. So we measured how often, using relative frequency, which is quoted by f/n, and as n gets larger, sample, and how often relative frequency works. So this is we have seen that probability, as far as the probability is concerned, probability helps in getting the real results from the sample. So if you talk more about the probability theory is the foundation for statistical inference, that is 50-50 chance of surviving. And if you take an example of that, like 50-50 chance of surviving in operations, 95% certain that he or she has a stomach cancer. So 9 out of 10 patient takes drug regularly, and when you talk more about the probability, I think it expressed in terms of percentage generally, and expressed in terms of fraction mathematically. So probability of occurrence between 0 and 1. So about probability, so a number that represents the chances that a particular event will occur for a random variable, that is odds for winning lottery, chance of rolling a 7 when rolling 2 dice, percent chance of rain in a forecast. So the frequent definition of probability used in statistics. Now prior to going to the depth of the various the terms or the terminology which we usually use in probability, either it could be experiment or events, we just want to throw a light on the history of probability. So generally in a day-to-day conversation, the words probability, possibly, chance, likelihood, etc. are commonly used, and you may have a rough idea of what is meant by these words. So we may come across the statements like the train may come late today, the chances of winning the cricket match. It means there is uncertainty about the happenings of the event, and we live in the world where we are unable to forecast the future with complete certainty. Our need to cope with the uncertainty leads us to the study and use of probability. In statistics, the term probability is established by definition, and it's not related to belief. So the concept of probability is as old as civilization itself. As you know, gambling is an age-old malaise. Gamblers have used the probability concept to make bets. The probability theory was first applied to gambling and later to the socio-economic problems. The probability theory was later on applied to the insurance industry, which evolved in the 19th century. This concept was used to determine the premium to be charged on the basis of probabilistic estimates of the life of expectancy of the insurance policy holder. Consequently, the study of probability was initiated at many learning centers for students to be equipped with a tool for better understanding of many socio-economic phenomena, and lately the quantitative analysis has become the backbone of statistical application in business decision making and research. So if the condition of certainty only were to prevail, life would have been much more simple. As is obvious, there are numerous real life situations in which conditions of uncertainty and risk prevail. Consequently, we have to rely on the theory of chance or probability in order to have a better idea about the possible outcomes. There are social, economic and business sectors in which decision making becomes a real challenge for the managers. They may be in the dark about the possible consequences of the decisions and actions, and due to increased competitiveness, the stakes have become higher and cost of making a wrong decision has become enormous. So, if you talk more about the meaning of probability in our day-to-day life, the probability or chance is very commonly used term. Sometimes we use to say probably it may rain tomorrow, probably Mr. ABC may come for taking his class today, and probably you are right or probably you are wrong. So all these terms, possibility and probability convey the same meaning, but in statistics, probability has certain special connotation, like in layman's view. The theory of probability has been developed in 17th century. It has got its origin from games, tossing coins, throwing a dice, drawing a card from a pack. So in 1954, Anthony Gorband had taken an initiation and an interest for this area. So if we compare probability with statistical reasoning, we say in that way, like, so we know exactly the proportions of car makes in India. We can find the probability that the first electric or hybrid car we see in the street, which is a need of an hour in the 2020, we see the street is made by Google or Tesla. This is probabilistic reasoning, as we know the population and predict the sample. Now suppose that we do not know the proportion of car makes in India but would like to estimate them. So we observe a random sample of cars in the street, and then we have an estimate of the proportions of the population. So, and this is called statistical reasoning. So on the other hand, there are certain uncertainties also. So managers often base their decisions on an analysis of uncertainties, such as what are the chances that sales will decrease if we increase prices? What is the likelihood a new assembly method will increase productivity? What are the odds that a new investment will be profitable? And if you talk more about probability, probability is a numerical measure of the likelihood that an event will occur. Probability values are always assigned on a scale from 0 to 1. A probability near 0 indicates an event is quite unlikely to occur. A probability near 1 indicates an event is almost certain to occur. So there are certain abbreviations or the terms which are going to be used: experiments and events. An experiment is the process by which an observation or measurement is obtained. An event is an outcome of an experiment, usually denoted by a capital letter. The basic element to which probability is applied: when an experiment is performed, a particular event either happens or it does not. So probability as a numerical measure of the likelihood of occurrence. And if you see, it varies. What we have talked about, it varies from 0 to 1, and the event is very unlikely to occur. If the 0 is there and 0.5, if the value is, the occurrence of the event is just as likely as it is unlikely, and the event is almost certain to occur if the value is 1, if the probability value is 1. So this you can see with the help of the figure, which is quite self-explanatory over here. So statistical experiments. So in statistics, the notion of an experiment differs somewhat from that of an experiment in the physical science. In statistical experiment, probability determines outcomes. Even though the experiment is repeated in exactly the same way, an entirely different outcome may occur. For this reason, statistical experiments are sometimes called random experiments. So an experiment and its sample space. An experiment is any process that generates well-defined outcomes. The sample space for an agreement is the set of all experiment outcomes. An experiment outcome is also called a sample point. So an experiment and its sample space. So if you are going to talk about experiment, toss a coin, inspection apart. When the experiment is toss a coin, experiment outcome is head, tail. Inspection apart, it is called defective, non-defective. And conduct a sales call, purchase, no purchase. Roll a die, that is 1, 2, 3, 4, 5, 6 is the experiment outcomes, and play a football game. So experiment outcome is win, lose or tie. So what exactly the importance of probability is? The concept of probability is of great importance in everyday life. Statistical analysis is based on the variable concept. In fact, the role played by probability in modern science is that of a substitute for certainty. And when we are going to discuss more about the probability, there are certain the points which come up, like the probability theory is very much helpful for making prediction. Estimates and predictions form an important part of research investigations. With the help of statistical methods, we make estimates for the future analysis. Thus, statistical methods are largely dependent on the theory of probability. So it has also immense importance in decision making. It is concerned with the planning and controlling and with the occurrence of accidents of all kinds. It is one of the inseparable tools for all types of formal studies that involve uncertainty. The concept of probability is not only applied in business and commercial lines, rather it is also applied to all scientific investigations in everyday life. Before knowing statistical decisions procedure, one must have to know about the theory of probability, and the characteristics of the normal probability curve is based upon the theory of probability. So what we observed that it had got a good theory behind it, and there are certain terms which we are going to use in our coming sessions. It's quite omnipresent in nature and quite useful. So if we talk about the random variable, it is numerical quantity that takes on different values depending on chance. If you talk about population, the set of all possible outcomes for a random variable, only hypothetical population, not a population of a people. An event, an outcome or set of outcomes for a random variable. Probability, the proportion of times an event is expected to occur in the long run. Probabilities are always numbers between 0 and 1 corresponding to always. So independent and dependent variables are events are either statistically independent or statistically dependent. So if you go more into the backdrop of statistically independent, the occurrence of one event has no effect on the probability of occurrence of the other. And when you are going to talk about statistical dependent, the occurrence of one event gives information about the occurrence of the other. And which are independent? So your education, your income level, draw a jack of hearts from a full 52 card deck, draw a jack of clubs from a full 52 card deck, or the Gymkhana club win the National League match, or the other the cricket clubs or the IPL win the different cricket series. So this is all about the things. And if you talk more about independent and dependent events, so independent events, when two or more events are said to be independent, when the occurrence of one trial does not affect the other, it indicates the fact that if trial made one by one trial is not affected by the other trial, and also one trial never describes anything about the other trial. So if you take some examples, the event in tossing a coin are independent events. If a coin is tossed one by one, then one trial is not affected by the other. In a trial, the head or tail may conic, which never describes anything. What event will come in second trial? So the second trial is completely independent to that of the first trial. And if you talk about dependent events, the dependent events are those in which the occurrences and non-occurrence of one event in a trial may affect the occurrence of the other trials, and here the events are mutually dependent on each other. So if a card is drawn from pack of playing cards and it is not replaced, then in the second trial probability will be altered. So equally likely events are there. Events are said to be equally likely when there is equal chance of occurring. If one event is not occurred like other events, then events are not considered as equally likely. Or in other words, events are said to be equally likely when one event does not occur more often than the others. So there are certain examples which can defend this particular statement. If an unbiased coin or dice is thrown, each face may be expected to occur in equal numbers in the long run. In another example, in a pack of playing cards, we expect each card to appear equally. If a coin or dice is biased, then each face is not expected to appear equally. And simple and compound events are there, where simple events, we think about the probability of the happening or not happening of the simple events. Whenever we are tossing the coin, we are considering the occurrence of the events of head and tail. In another example, if a bag there are 10 white balls and 6 red balls, and whenever we are trying to find out the probability of drawing a red ball is included in simple events. So the probability of an event is viewed as a numerical measure of the chance that the event will occur. So if you talk about the event and outcome of an experiment or survey, rolling a die and turning up 6 dots. Elementary event, if you are talking about, which could be one of the component of event, an outcome that satisfies only one criterion, a red card from a standard deck of cards. Or if you talk about the joint event, an outcome that satisfies 2 or more criteria, a red ace from a standard deck of cards. So On the other hand, there are some more events like mutually exclusive events are there. The events are said to be mutually exclusive when they are not occurred simultaneously. Among the events, if one event will remain present in a trial, other events will not appear. In other words, occurrence of one preludes the occurrence of all others. For example, if a girl is beautiful, she cannot be ugly. If a ball is white, it cannot be red. If we take other events like dead and alive, it can be said that a person may be either alive or dead at a point of time. But life cannot be both alive and dead simultaneously. If a coin is tossed, either the head will appear or the tail will appear, but both cannot appear in the same time. So it refers that in tossing a coin, the occurrence of head and tail comes under mutually exclusive events. And probability as a ratio also, the probability of an event stated or expressed mathematically called as a ratio. The probability of an unbiased coin falling a head is 1 by 2 and the probability of die showing a 2 spot is 1 by 6. So these ratio called the probability ratio are defined by that fraction, the numerator of which equals the desired outcomes or outcomes and the denominator of which equals the total possible outcomes. So more simply put, the probability of appearance of any phase on a 6 phase is 4 spots is 1 by 6 or the probability desired outcome total number of outcomes. So the probability is number of ratio which ranges from 0 to 1 and 0 for an event which cannot occur and 1 for an event certainly to occur. So anyway, I think we have given a good glimpse about the probability. And we know that when we talk about statistics, when we talk about sample, and when we know the trend analysis, I think probability is one of the very important driving force, which is quite useful as far as the determination, as far as the analysis is concerned, or the assumption of the analysis is concerned. So in our coming sessions, we are going to apply some more advanced thoughts related to probability or the probability distribution and take some good numerical examples which can defend our statements in a more comfortable manner. Thank you very much.